Well, we've made it to chapter 3, and this intro video probably will be on the longer side, but if you've noticed, it's the only video that you have to watch tonight, so just bear with me. We are going to look at congruent figures for 3.1. So we've got some things to fill in your notes. Congruent, I can't say that word very well, congruent figures means that all sides are congruent. Here's a little congruent symbol. And all angles are congruent. So if you have two figures that are congruent, that means all of the sides are congruent and all of the angles are congruent. Specifically, we're going to look at some congruent triangles right here. So if you have congruent triangles, that means that all pairs of corresponding parts, so you can go ahead and write this in with me, parts are congruent. So what we mean by corresponding parts, you know, a set of sides, a set of angles. Here we have two triangles. We got some corresponding parts to fill in. We're going to go ahead and say that angle A is congruent with angle D, so I'm going to put one little curve on those. Angle B, I'm going to put two curves on, is congruent with angle E, and then angle C, we'll get 3 because that's a third angle. So those are corresponding parts. You can see angle A is corresponding and congruent to angle D, and so on. Let's go ahead and fill in our sides. Side AB is congruent to side DE. Side AC, the hypotenuse of the triangle, is congruent to DF. And then our third side is congruent to the third side over here. So what we would say for these two triangles, we would say triangle ABC is congruent to triangle DEF. Now the way that we write that statement out, this congruency statement, matters. You want to make sure that the letters line up. So for example, because I said A first in this triangle on the left, I have to find its corresponding angle over here and start with that same letter, D. So the A went first, and then I went to B, which has the two curves, which means in the second triangle, the one that has the two curves has to go next, which happens to be E, and then C is congruent with F. So you want to make sure that the order that you write out these congruency statements is accurate. So what are the corresponding sides? Corresponding sides for this triangle, we've got side AB is congruent to side DE. Remember, you do want to put those segment bars above those. We've also got AC is congruent to, now AC had the two dashes, so which one has the two dashes on the right? DF. And then the last one is BC is congruent to EF. So these are corresponding parts. See, these are corresponding parts that happen to be sides. Now we also have corresponding angles. Let me just slide this up for a second. Our corresponding angles, we've got angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. So those are all of your corresponding parts. So corresponding parts are the parts that are, let's fill this in, congruent from one figure to another. So we've got this great property that we want to make sure that we know about and know how to use. It can be used a lot in proofs. In this first, well, it's the reflexive property. I know you guys can read that. In this first figure, we actually have two triangles. We have triangle ACB, and we also have triangle ADB. So if you have a figure with multiple triangles, you want to think about separating those out in your mind. So you have two separate triangles. And a reflexive property means that they share a side. So you can see what side do they share? Right here. That's a corresponding part in both triangles. So we would say that side AB in the triangle on the left is congruent to side AB in the triangle on the right because they happen to be the same side, which would mean that they are the same length. So they are congruent. The figure on the right looks like a rectangle, but you can see that we're cutting it across the diagonal here, giving us two triangles. So let's just identify the triangles. We have triangle WZX, and we also have triangle YZX. Z's look a little bit weird. So the reflexive property tells us that this shared side gives us some congruent parts or congruent sides. So side ZX is congruent to side ZX. So this might seem kind of obvious, well, of course those would be congruent to each other. The reason why we want to make sure we know about it is we use the reflexive property in proofs a lot. If we need to prove that two sides are congruent that happen to be a shared side, when we do the proofs in the two columns, we would state the reflexive property as our reason. So whenever a side or angle is shared, it's congruent to itself. You guys are going to hear some words used. We want to make sure we understand what it means. If you hear something that's called an included angle or an included side, we just want to make sure we understand what that is. So an included angle is an angle that is bound by two sides. And bound by two sides basically just means that it's in between two sides. So we've got this triangle on the right, and this first just quick little example, you have two sides, AB and AC. So here's AB and here's AC, and so what we're asking is what is the included angle? So these two sides actually meet at an angle, and it's the angle that's in between the two sides. So the included angle would be angle A. All right, so what is the included angle between BC and AC? Well, here's BC and here's AC. So these two are going to come together at one angle. That's the angle in between the two sides. So our included angle is angle C. So just like included angle, you can also have included sides. An included side is a side that is bound by two angles or is in between two angles. So this first one, you got angle A and angle C. So what is the included side in between those two angles? Well, it's going to be the side that connects the two angles. So that's going to be side AC. What's the included side between angles B and angle C? Well, here's angle B, here's angle C. The included side is the side in between them, and that would be side BC. So the next couple of slides, we're going to look at some examples that have conclusions made based on the given information, and just can we come up with the reason why it's okay to make this conclusion right here. So we've got a lot going on in the figure on the right. We're actually going to use this figure on the right for 4 examples. A lot of triangles, lots of angles, and we're just going to focus on just the little bit that they give us in the given. So first, our given is FP and GP are angle bisectors. So let's find FP. So here is FP right here, and GP is right here. Well, that was kind of sloppy. All right, I just redid that a little bit cleaner. So do you guys remember what angle bisectors are? Angle bisectors tell us that you take an angle and you bisect it into two congruent pieces. So if we look at angles 5 and 6, if that FP is a bisector, that means that these are congruent to each other. Now they also gave us another piece of information. They said that angle 5 is congruent to angle 7. So if angle 5 and angle 7 are congruent, they're each going to get one little curve. And here's where we're using a little bit of logic. Because of the angle bisector, we know that 5 and 6 have to be equal to each other, and 7 and 8 have to be equal to each other, and they said that 5 and 7 are equal to each other. So basically what we have are 4 angles that are equal in measure. So the conclusion that's being made is angle QFG. So let's figure out Q to F to G. So this big angle is congruent to angle RGF. So what is the reason why we can say that those two angles are equal to each other? Well, if you think about it, does it make sense to say that angle 5 plus angle 6 is equal to angle QFG? Remember how if you add up two smaller angles, it's going to equal the bigger one? Well, you also could say that angle 7 plus angle 8 is equal to angle RGF, this other big angle. And because these are equal to each other, that means that the big ones will be equal. And what did we just do to figure that out? We used addition. So we have this addition property. That's our reason. All right, so hopefully that one made sense. Let's look at another one. So this one we're given that PF is congruent to PG. So we want to find PF. Here's PF right here, and here's PG. So those are two congruent sides. So we're going to give each one of those a dash to show that they are congruent. We also know that QG is congruent to FR. So QG is kind of this big one right here, is congruent to FR, this big one. So I'm just going to kind of show that this is congruent to this big one right here. All right, so we see what's going on. We've got these that are congruent to each other. We've got the big ones that are congruent to each other. So someone went ahead and looked at that information and concluded that QP, which is right here, is congruent to PR. Now, how did we know that that was going to be true? Well, if you take the big one and you subtract out the one that we know about, you're left with just that little segment. And because the other one, this FR, is the same length, if you take that big one and take away the one that's congruent to the other one, we're left with the same length of segment. And so because we're taking it out, that's going to be a subtraction property. So a lot of what we do in geometry is, we're given some information and we make these conclusions. We just have to be able to give the reason why. And we have to have a mathematical reason for explaining the conclusion. All right, this is the last slide of the intro video. Same figures again, just different information. So in this first example, we're given angle 5 is an acute angle. Now what's an acute angle again? Remember those cute little angles? That's less than 90 degrees. And then they also told us that angle 5 is congruent to angle 7. So I'm going to go ahead and mark that congruency. Here's angle 5, congruent to angle 7. So make sure you guys are marking those in your notes. So the conclusion that somebody made is that angle 7 is an acute angle. Well, what's the reason for that? I mean, it kind of makes sense, doesn't it? If angle 5 is an acute angle and they're congruent to each other, then wouldn't angle 7 be an acute angle also? Yes, it would. And without maybe realizing what it's called, that's called a substitution property that allows us to make that logical conclusion right there. So it's almost as if because 5 is acute and they're equal to each other, then we can substitute in 7 and know that 7 is acute as well.
All right, last one here. Basically, we're given just the diagram as shown. And then the conclusion is that angle FER is congruent to angle GEQ. So let's figure out where these are. FER is this angle, is congruent to angle GEQ. So you could look at this as kind of like you have two triangles right here. So you've got this one right here, and then you have this one over here. Do you guys see those two triangles? And we talked about the reflexive property earlier in terms of having a shared side. Well, that works with shared angles as well. You can see that these two triangles share this angle right here. So we can conclude that this angle in the pink triangle is congruent to the same angle in the blue triangle. And then just the reason that we use to back that up is we say that's our reflexive property. So if there's ever something that is shared by two triangles, you can say that they are congruent to each other by using the reflexive property. And there's your 3.1 notes.